Find the derivative of y equals f of x times g of x times h of x. Then evaluate y prime of 3, where we have that information. Now, y here is the product of 3 functions, all of them unknown. F of x times g of x times h of x. Y can therefore make use of the product rule. This is actually the triple product rule, where we have 3 functions multiplying each other. The derivative, y prime, or dy dx, will follow a similar format as the product rule, but one term at a time here. The derivative of the first, f prime of x, times the second and third left alone, plus the first left alone times the derivative of the second times the third left alone, plus the first left alone times the second left alone times the derivative of the third. You take the derivative of each one at a time and leave the other 2 alone and add all those terms together. There's our derivative y prime or dy dx. The next thing to do is evaluate y prime of 3. So y prime of 3 equals to, plug a 3 in for each of the x's, f prime of 3 times g of 3 times h of 3, plus f of 3 times g prime of 3 times h of 3, plus f of 3 times g of 3 times h prime of 3. Now, all these evaluations can be determined by the information that is given to us over here. So let's look up those values and plug them in. So we have for f prime of 3, that's a 2. G of 3, that is a negative 2. H of 3, that's a negative 1. Plus f of 3, that's a 4. G prime of 3, that's a negative 5. And h of 3, that's a negative 1. Plus f of 3, that's a 4. G of 3, that's a negative 2. And then h prime of 3, that's a 1. So y prime of 3 equals 2 times negative 2 is negative 4 times negative 1 is a positive 4. 4 times a negative 5 is a negative 20 times a negative 1 is a positive 20. So 4 plus 20. And then 4 times a negative 2, negative 8 times a 1 is a negative 8. 4 plus 20 is 24, minus 8 will give us 16.